Hello, my name is Mariah. The reason why I'm taking Gen Chem 2 is because it's required of me to take it so then I can get my associate's degree in biomedical science. I can explain really well from Gen Chem 1 is chemical equations, like molecular, complete ionic equations, and net ionic equations. So I decided to use this example. Potassium iodide, which is aqueous, plus lead 2 nitrate produces lead 1 iodide and potassium nitrate, which is aqueous. Well, first you have to know that all of these separate elements. So potassium is an element. Iodine is an element. This is lead. This here, well, the NO3 is nitrate, and it's actually a polyatomic atom. So it's made up of at least 2 different elements, nitrogen and oxygen. But there's 3 oxygens in here. That makes it a nitrate. Over here, we see lead, and then iodine, as well. But this one makes a solid. So somewhere around here, the mixture of the two of lead and iodine makes a solid. This is an element as well, potassium, and then once again you see that nitrate. Now before we can continue and find the net ionic equation and the complete ionic equation, we first need to get this balanced. So we write out all the elements and the polyatomic atoms on each side. So what I like to do is that I like to write down the middle. My red pen's just not working today. Right down the middle, I like to write out what's on each side to see what we need to add in the coefficient. A coefficient is usually the big number that goes in front of each of the compounds. So it can go in front of this one, or this one, or this one, or this one. But we're going to see which one needs a coefficient in front of it. So we first start off with potassium. I only see 1 potassium atom on this side. So I'll write 1 K. Okay, this pen is not working. Hopefully this one works. This one's also not working. There. You'll write 1K. Now for the iodine. The iodine. You only see 1 iodine on this side. So I'll write 1 iodide. Now for the lead, there's also only 1. So I'm gonna write 1 lead. And then for the nitrate, there's only 1, but this subscript number 2 means that there is 2 of this polyatomic atom. So that means there is 2 nitrate atoms. So you're right. It's much easier not to split them apart because it is not split apart on the product side. So let's not split it apart in the reactant side. That way it's easier to find the answer. Now let's move to this side. The first one is lead. I also like to write on the same line when we're talking about the same atom. So there's one lead here. So just like it's on this line, I write it on this line. One lead. And then for the iodine, there's two. But there's only one iodine on the other side. So we know that we're definitely going to have to increase the iodine. And then for potassium, there's only one. And for nitrate, there's only one. So then you write one nitrate. So then we look. One potassium. Okay, it's good on both sides. Wait. It's always important to check your work. One iodine, two iodines. Okay, so this something needs to happen. Here is fine, but these two, there's two nitrates here and one nitrate over here. So something needs to happen as well. So let's see how we can balance these equations so that we have the same number of each atom of element on each side. So let's start off with the first one that we found that needs to be changed. So the iodine, it is 2 here, but 1 over there. So we need at least 2 on this side. So with a pencil, sorry, I was looking for a pencil. Now, so let's write 2 in the front, which would make that you would have 2 iodines, but you also have 2 potassium atoms. So now we need another one over here for potassium atom. So we could write 2 in front of here, but would make that we have 2 potassium atoms, but also 2 nitrate atoms, which is perfect because we have 2 nitrate atoms here and 2 nitrate atoms on the other side. So now, when we look, we have 2 potassium atoms, 2 potassium atoms, 2 iodine atoms, 2 iodine atoms, 1 lead atom, 1 lead atom, 2 nitrate atoms, 2 nitrate atoms. So now we know that this equation is balanced because if the same amount of atoms that are on this side are the same amount of atoms that are on this side, then that's how you know that the equation has been balanced. But let's find out which ones actually reacted with something. And that is what the complete ionic equation starts to do. Now, for the complete ionic equation, also abbreviated as CIE, we have to split all the aqueous compounds into ions. And to do that, it is much easier now that we have written out how many atoms are in each side, and we make sure that it's balanced. It's easier to write the complete ionic equation. So first, we start off with potassium. We already know there's 2 potassiums. But which charge does potassium have? Well, if we look at our periodic table of elements, K is right here, and it's on the first table, the first column. So it has a positive 1 charge. So we write a positive 1 charge. And we can write AQ just so we don't forget. Now, next one is I, or iodine. So we know that there's 2 iodines. But what charge does iodine have? Well, iodine is found right here. And it is on this column. So it has a positive, it has a negative 1 charge. So rewrite negative. Yeah. Now next is the lead. Lead, there's only 1 lead. But it is with a polyatomic atom. And this specific polyatomic atom has a charge of -1. But there is 2 of them. So 2 polyatomic nitrates to 1 gives it a positive 2 charge. Then we go to the polyatomic atom, and there is 2 of them right here. So we write 2 nitrates. And like I said earlier, this polyatomic atom has a -1 charge. And now we're going to the reaction side. Writing it all out. Probably gonna have to write out because the paper's not big enough. The product side, it starts with lead. And we wrote earlier, the lead is a transition metal. So usually it takes the charge of the opposite of what you have for the negative, because it's in transition metal. So iodine, like I said earlier, I am wrong. This is why it's important. Like I said earlier, you're only writing or splitting apart what is aqueous, but lead iodide is a solid. That means that it doesn't split apart. It just stays this way. It stays PbI2, and you put the little s right there. And then this one actually is one we split. So you have 2 potassiums, and like I explained earlier, it has a positive 1 charge. And then we have the nitrate again, and that, like I said earlier, has -1 charge. Now, that we have written everything that can be written out, separated into ions, we find the spectator ions, which are basically ions that on the product and in the reactant side are exactly the same. That they don't change or anything like that. So, splitting it apart, we have K, which is 2 Ks with a positive plus. On the product side, there's also a 2K plus. So, I'm just going to circle here. We found one spectator ion. What about I? There's 2 I ions, negative ions. But you see here, I can't be split up because it has turned into a solid. So, it is not a spectator ion. What about lead? It is also not a spectator ion because it is with iodine. Now, nitrate. Both in the reactant side and in the product side, it remains the same. So we circle this one as well. Now that we found all the spectator ions, we, when writing the net ionic equation, we only include the ions and the product that we have to show what has actually reacted. The net ionic equation, also known as NIE. Like I said, the net ionic equation is comprised of all the ions and the products that were not considered spectators. The iodine and the lead ions were not spectators because they come together to make a solid in the product. So we write just that. We write 2I negative AQ plus PB 2AQ reacts to make lead iodide. And that is all to write that net ionic equation. Now, when it comes to my muddy points, I would think that if there's anything that I really struggled with the most and I still have some confusion on how to do it, would probably be thermochemistry with the Q and the MCAT. It's just then I had a hard time with it because a lot of it didn't, I guess, click in my brain. So I think that I need the most help with that. Okay.